All right, ladies and gentlemen, time once again for the only coast to coast radio show that's all about the information economy. It's time for Inside Analysis. Yours truly, Eric Kavanagh, is here. And folks, we got an all star cast. Our buddy Mark Madsen of Third Nature is with us, as is Roger Cummings, CEO of a company called Peak AIO. And folks, we're going to talk about getting AI ready. What does that mean to get AI ready? Well, first of all, you must have heard about the astonishing amounts of money being poured into data centers all over the country. Meta's talking about it, OpenAI is talking about it, Google, Rackspace, Oracle, everyone and their grandmother is building AI data centers now. And they're building so many of them that there are regulations propping up to say, hey, you better have your energy in line before you start building these data centers. In fact, one of my good buddies, Malcolm Chisholm, down in Naples, Florida, he was saying, yeah, my power bill keeps going up and my water bill keeps going up and they're building these AI data centers everywhere. I wonder if I'm subsidizing AI. And short answer is probably. That's probably
Yeah.
true. So these things do use tremendous amounts of energy. Now they don't have to. There are technologies in place that can really optimize the energy usage of these things. And we're going to talk about some of that stuff today. And we will get into the weeds. So feel free to have ChatGPT up next to you so you could be asking questions about what RDMA means and what NVMe over fabric means and all this other kind of stuff. Non-volatile memory express, right, over fabric. Really, really cool stuff that's happening out there in the hardware space. And my business partner, Dr. Robin Bloor, a pretty famous guy who kind of invented the independent IT analyst firm concept about 30 odd years ago. He said to me years ago that innovation always starts at the hardware level. And then it goes to the software, and then it
Mhm.
goes to the apps, and so on and so forth. But when you change something fundamentally at the hardware level, you open up all sorts of new opportunities. So, flash memory, for example, was a massive disruptor in how we store information. And then some smart people figured out, hey, wait a minute, we can use this stuff. And then gamers, let's not forget about the gamers who have kind of made this whole AI revolution possible. Why? Because of GPUs, because of graphics processing units, which are very good at parallelizing workloads. Well, what do you need when you do AI? You need to parallelize workloads. You need to split the job up onto lots of little teeny tiny jobs and send it out across the transom to process all that information and bring back your results. So there are other fun topics we can talk about, like I love parallel file systems. Like, ooh, that sounds like a sci-fi movie. Parallel file. What is that all about? Well, it's a very interesting concept that's very powerful in the world of data science and especially in like life sciences. And one of the ways that I got into this space was through another company in this industry called Hammer Space, which I love the definition. Hammer Space is the space from which a magician pulls things, like a rabbit out of a hat is literally a rabbit out of hammer space. But Roger knows a little thing or two about those folks, and in fact, his business partner had something to do with a previous company, Fusion IO, which is where NVMe kind of came from. And I'm throwing out all of this detail just to kind of cast a tapestry here so folks understand what's going on out there. There's a tremendous amount of innovation happening right now in how you build these systems and how, of course, you deploy the systems and run them. And there are millions of dollars to be saved if you do it correctly. If you do it incorrectly, you're going to spin your wheels and it's going to be very
Mhm.
unpleasant. MIT just came out with a study that said 95% of AI projects fail. You always wonder about how they sort of did the research and what that actually means. What does it mean to fail? Right now, I think most of the benefits from ChatGPT and Gemini and Claude and so forth are coming from personal productivity, which is a very different use case than enterprise caliber solutions. So we're all trying to get to that enterprise space. But to get AI ready, that's what we're talking about today. Companies like Peak AIO are doing very interesting things to help you optimize your infrastructure, which of course is very expensive. And with that long
Mhm.
introduction, allow me to bring in Mark Madsen of Third Nature. Welcome back to the show, Mark. These are amazing times, and I think we really are at an inflection point, a very serious one. But boy, high risk, high reward, and high risk. What do you think, Mark?
Yeah.
What's going on?
Yeah, it really is. I've kind of enjoyed it because, I started out in very close to hardware and operating system kernels and things like that. And so all of a sudden all that, like in the last 10 years, got called back into question because, well, really like the thing you didn't mention, virtualization is what kicked it all off, right?
Wow, right.
When you had a high performance computing cluster, the way it worked was here's a farm of, 500 computers, all lashed
Yeah.
together over a super high speed network and all lashed together over a bunch of file storage, which is remote, but the remote file storage is just there for cold store, and you have to take all your data and
Mhm.
shove it into that cluster. And if you've got, 500 terabytes of data, a petabyte of data, more, and you got to shove it into a cluster, you wait a few days, right? And
Yeah.
so, and then that cluster is set up to run that thing, right? And what was the thing? It was like, let's simulate a nuclear bomb. Let's simulate the weather, right? And
Yeah.
and so it's one model smeared over all those machines. And then when you're done, you get all the stuff off those machines and you set it up for the next big job, right? So it's the equivalent, if you were an enterprise, of mainframe batch going
Yeah.
to distributed computing, right? Suddenly I can run
Mhm.
different applications different places. So I could take 200 nodes of my cluster and run one thing, while 300
Yeah.
nodes of my cluster are running something else, if I'm willing to sacrifice 10 to 15% of my performance, right?
Yeah.
Except that when we talk about storage, it was more like 50% of my storage or something, and you didn't have the flexibility, but then along came all this, stuff that would make the file system flexible in the same way that the virtual compute was flexible. And once you had the two pieces, the computing and the storage, also with the networks, able to be partitioned more, in a finer grain, you could do different things.
Yeah.
And and now suddenly we don't have month-long setups and breakdowns, or we don't have to if we have other things. And that opens up HPC computing to an enterprise market. And I'm talking
Yeah.
about this stuff was like 10 years ago. So to me, that sort of is what really set the stage. And I'm kind of curious how Roger, how you see the whole uh, you know, market evolution as we go from that governmental scientific computing market
Hmm.
into a more general market of corporate computing and enterprise work.
Yeah, I think thanks for having me. First of all, I appreciate your time very much. I think you hit the nail on the head. We say it a little bit differently, right? Because this is a an AI gold rush, right? And
Yeah.
and peak is the picks and axes that are picks and shovels that are making it work. But to your point is the way we say it is we're bringing AI. As AI has grown, we've seen the characteristics of AI very much like HPC, as you talked about. We see it in a way that we need, because the data is so large and the environments are so large now. It's bringing the applications to the data, right? You can't move data anymore, right? You have to bring the infrastructure to that application. So where we see peak play in, and again, we're a software defined level, excuse me, a software defined layer that sits on commodity hardware. Again, moving that infrastructure to the applications, where we improve storage performance and scale out file system performance. Why is that important? Because the great thing about what we do, and our secret sauce was providing high performance in a 2U or a single server infrastructure. And to your point, Eric, as well as doing that in a cost-effective way. You knew something had to change. The infrastructure had to change when you started seeing water-cooled
Mm.
racks to cool these servers down. There's so much heat being generated. So that was where we started. And we started by being super efficient, kind of our early secret sauce when our competitors are bringing in 12 to 10 servers just to get line speed performance. We could do it in one.
Mm.
So you think about the savings in cooling, electricity, and maintenance and management of that. So that's step number one. Step two is we recently introduced, and we'll have more about this in the upcoming Supercompute 25, about our open source parallel network file system. And to your point, Mark, it's taking that file system and allowing you to be more flexible in how you use it. But the next step, I think, is critical. And where we're going as an organization is becoming more application aware. So to your point is HPC has various different workloads, right? And you go from one agency to the next agency, completely different businesses. As you mentioned, one's weather, one is nuclear fission. So um, understanding those workloads and the characteristics of the files that are involved, the computation that is involved, and the processing compute needs and requirements is really critical. So as you see uh, peak mature, you're going to see us have a better understanding of that. And to your point, Eric, is of utilizing or breaking apart these jobs across a parallel network file system with AI. The same is true with these organizations have thousands of GPUs. How do we make sure that we're utilizing that GPU farm, for lack of a better word? How do we make sure that we're utilizing those GPUs and moving data or moving these workloads to the appropriate GPU infrastructure? And that's where you're going to see you've heard things like intelligent data placement and things of that nature. So that's where you're going to see us grow and making sure that we're optimizing that infrastructure. Again, reducing power, reducing cooling associated with that infrastructure.
Right. It's funny, like when I look at the market, because I don't do much work with government agencies, right?
Yeah.
I but I came out of that world of high performance computing a long time ago, and that has like its ways of planning and its ways of acquiring this stuff, and it's like, okay, we just got $500 million. Let's go build a data center and fill it with 3,000 computers, and
Yeah. Yeah.
and then, of course, it's a big capital budget, and it just then that stuff kind of sits there for the next few years and depreciates, and it's tied to projects. But then you get into the corporate world where you might have similar things, right? Like, pharma's gone out and done all kinds of stuff in
Yep.
different areas of bioinformatics, and
Yep.
it's still very science centric. And so you have people who are capable of doing that, but then you roll into a Walmart, big
Yep.
corporation, or a Target, or any of the myriad tech companies trying to surveil your every move. They have, big compute clusters and big storage, but they don't have that scientific computing background. And so they budget differently, they buy a little bit
Yep.
differently, and their
Yep.
workloads are a little bit different. And
Yep.
then, you roll into like your standard enterprise, which could still be really big, like, pick, I don't know, an auto manufacturer or John Deere or something like that. And, you've got different stuff now because you're not doing these
Yep.
giant simulations, you're running or building or running, right? Because there's kind of
Yeah.
this two sides to that. These big models to do things. It could be simulation, or it could be a deep learning model, or it could be,
Yep.
today's I'm fine tuning a language model.
Yep.
And each one of those just looks a little bit different and gets thrown out there. And so there's this diversity where there didn't used to be a diversity that drives different uh, different workload characteristics. So
Yep.
how do you guys fit, when you look at both, I got to fit ease of use
Yep.
to Joe Blow at Target, and I've
Hmm.
got to fit a totally different skill profile for somebody who's spent 20 years at Los Alamos, like very
Yeah.
different skill levels requiring very different features built into the product. So
Yep.
how does that fit in the market in your mind?
So love the question, because I think there's a baseline to this. I think that peak AIO addresses, and that is failure can't be uh, such a financial burden to organizations that they just don't give, they give up, right? Because right now I was recently at a conference that they said failure costs too much, and it really doesn't have to, right? We're providing an infrastructure that is modular in nature, so they can grow as their application grows, they can scale with us. So we're not trucking in infrastructure that's millions and millions and millions of dollars. They can start very economically with our solution, and they can grow as they grow. So that's number one. Number two is we're building in AI. as I mentioned before, we're going to understand those workloads really, really well. But we also, because we're in the infrastructure, we understand the type of disks that they have. They understand the type of switches that we have. We understand the overall infrastructure of that application. So what's going to happen is we will have AI inside of our own solution.
Hmm.
So hey, this is the type of infrastructure. So we will have that infrastructure. We'll understand that infrastructure, and then we're going to adjust the characteristics of it, whether it's more CPU based or GPU based.
Hmm.
To your point is we have to make sure that we're providing the most optimized infrastructure for that application. And that is an element of both hardware, but software too, to make sure we're utilizing or optimizing, I should say, that infrastructure the best we possibly can. And a great example, we were just talking to a customer the other day. They gave up on an AI application. Now, this was a sales oriented for their sales force, but it would just cost too much to run.
Hmm.
And we look at that as like that is what we need to address. Is yes, there's a gold rush going on. We need to be a very efficient picks and shovels to make sure that when they are running those applications, we are improving the success of AI and being able to offer that in a very economic footprint.
Yeah, and I'm going to throw out there, we're up at our first segment here, observability, which has
Yep.
exploded in the last few years. It's really very interesting. And this
Hmm.
thing called open telemetry came along too, which I just love because it's a standard and good things are built on standards. HTTP is a standard. We have the internet. It's very, very
Correct.
successful because we have standards that we agree to across industry, and then people can collaborate and focus on their secret sauce, as Roger was
Yeah.
just talking about his. But we'll get into that in the next segment, folks. I think it's very, very interesting that you can learn tremendous amounts of how these things are actually running. And that is pretty important. It's like knowing how a car runs. It like helps you fix
Yeah.
the car when the car breaks. Same thing with AI solutions. We'll be right back. Don't touch that dial, folks. You're listening to Inside Analysis. All right, folks, back here on Inside Analysis, talking to Mark Madsen of Third Nature and Roger Cummings of Peak AIO, a very interesting company in the AI space, optimizing AI workloads. This is very, very expensive stuff. And boy, you could burn through millions and even billions of dollars and get no value, and that is no bueno. And so, luckily, we have all this observability these days, which I think exploded because of Kubernetes. And for those who don't know, what Kubernetes is. It's a very interesting technology that came out of Google. It sits on top of Docker, which was always a also very interesting technology, and containerizes compute. So the best expression I've ever heard or description for a business layperson is to think of a container as holding a system process, like a certain function that your computer does. The example I give is a fairly robust one, like a spell check. You can run a spell check in your Microsoft Word, you can run it in Adobe Acrobat, you can run it in different places, but that is a service that you're running in some certain place. That's like I say, it's a fairly sophisticated one. But these little containers, they are ephemeral and they spin up, and it's just amazing what they can do. And it really revolutionized enterprise computing. I remember it was MapR in like 2015, I want to say. I was on a briefing. They were the third big Hadoop vendor. First it was Cloudera, then Hortonworks, then MapR came out. Did some very interesting things. We learned a lot from it. They got absorbed by HPE, as I recall. But they came out and they were telling me in 2015 that they were re-architecting their entire platform to run on Kubernetes. And I thought to myself, holy Christmas, you're a data platform company. If you're re-architecting your entire system to run on Kubernetes, this is the next best thing. And it's now everywhere. I mean, Kubernetes won that game. There are alternatives to
Mhm.
it, but it's out there
Yep.
everywhere. And I think because of that, we saw this observability because it's doing all these things. And I mean, Alex
Hmm.
Gallego from Red Panda, which is like a Kafka alternative, he joked to me a few weeks ago on his show. He said, "Yeah, well, if we ever get to artificial general intelligence, maybe it'll figure out how Kubernetes works,"
Yeah.
which is funny from a
Ain't
guy who,
that the truth?
who
I don't
does
think of
cool
it the way
stuff.
Yeah.
you do. It's like little containers for functions. I think of it as having 100 cats. And each cat you tie a little note to, and you want it to get to somebody else, and then you set the cat loose, and then somebody shakes a bottle of catnip, and you really hope that somehow your
Yeah.
message gets to them. It's
Yeah.
it's a herding cats platform that yeah, it's too complicated for most normal people to run, and so you end up with all these layered monitoring solutions like you're saying, and I think before the break you said something, you talked about it being sort of like, knowing how this thing runs, like, example of a car. Well, what about the example of a plane? I think that's more appropriate because,
Yeah.
you know, cars gently roll to a stop and you call the AAA or you get a tow truck and you get your car running again. You don't really do that in a plane. And a compute cluster running a big job is like an airplane where suddenly the flaps stop working. And then,
Yep.
you got to figure out how you're going to get your flaps working. And so the monitoring and all that infrastructure helps you, but the point is not so much that the monitoring's there. It's like, oh no, what's wrong? The flaps stopped working.
Yep.
Darn. It's more like you need reliable technologies that are
Yeah.
layered in, from the hardware through the firmware, through the operating system, through all the
Yep.
different layers that get to the point of me want fly plane.
Yeah.
And and so there's that aspect. And then the second piece is just, okay, so you do have failures, you know. Uh,
Hmm.
Great. I can detect the failures because I've got an observable platform. How do I
Hmm.
recover from the failure before the plane hits the ground? Or in the AI model space, two nodes are gone out of
Yep.
20. And so now what happens? Because the other 18 are churning away on their work and then they're waiting for these two so that you can move on to the next step. And if they don't in time, everything stalls and then it's like a train wreck. Mixing my
Yep.
metaphors here. It's like a plane landing on a train. So I don't think a lot of people understand that that's kind of the nature of this beast when you talk about compute in clusters where things are
Yeah.
happening synchronously and they need to stay in sync because that's the system. The computer isn't the system, the cluster is
Yes.
the system. And your model is what's running in that cluster. And if a piece of it goes missing, like your leg, well, then you hope your leg's going to come back in the next 5 minutes or you're going to fall over.
Hmm.
Yep.
So uh, maybe Roger, you could talk a little bit about like what is failure at this level in the storage piece, which is where you
Yep.
guys are playing. Like,
Yeah.
what does that look like, and how does that recover, and what's common in this space? Because there's a lot of, I'd say, people just assuming it runs like AWS and everything comes back after 5 minutes.
Yeah. And I think you bring up a great point because what was the purpose of Kubernetes is let's simplify the orchestration of things,
Yeah.
right? I don't know. I'm
That's a
not
good word.
sure, but if you think about what the cloud did for us, the cloud provided us a a layer of service, right? It provided us a layer of service that we can kind of guarantee that it's up, even though it isn't many times, as of I think it was this week at
Yeah.
AWS.
AWS.
But
Oops.
yeah, but what happens behind the scenes, it becomes very, very complex. It becomes a virtualized pool of resources that come in and out of service, that come in and out of availability. And what we need to do is we need to understand, and that's why it was so important for us to establish that base layer of performance, both on the storage and the file. So now we have a really good understanding of all your data. We have a really good understanding of your infrastructure, right? Including it can include cloud. It can include we can sit in the cloud, whatever that consists of. So we understand the level of services that we have to have based on the application, the infrastructure, and the performance or the compute necessary for those applications. We're going to we have intelligence that comes on top of that to really understand, okay, my resources are out over here. Where do I move those workloads?
Hmm.
So that becomes a level of service back in. It's so funny I talk about this, and I think back into our old days, right? We all have a little of the gray hair, right? But we talk about our old days. Is we came from the world of five nines, right? Now it's performance at all costs. But guess what? That complexity or that orchestration that's needed is going to require those five, maybe not five nines, but those availability aspects to our infrastructure. And our job is to understand those workloads and make sure that we can move those workloads so it doesn't interrupt some of the things that you're saying.
Interesting. That's a good point. I mean, so it is kind of like virtualization in a sense. What are you able to read when you talk about how you understand the workloads, you understand the data and the infrastructure? I mean, you're obviously scanning and pulling this information in, and you've built some
Mhm.
sort of a model that then can optimize what goes where at which point in time. I mean, basically, it's workflow orchestration to a certain extent. Just like in the
Yeah.
real world, you would say, "Hey, Bob's really good at this task. Susan's really good at that.
Yeah.
You do this, you do that." But how does that happen at that level of management of storage of data?
Well, what's I mean, you think of who we are today and who we are tomorrow will be far different, right? Because we're building on top of this frame, we're building on top of this foundation, right? Of you got to have fast performance, you got to have scale out performance. Okay, great, we have that.
Hmm.
Compute will be owned by the Nvidias of the world and others, right? But what we're doing is we're understanding from the model, our goal in time, understanding from the models down, right?
Hmm.
Once we understand the models or how if we can get insight into the models, if we can get insight into the data that you have, because we have that data, we can show how those models, if you're exercising all those models, the visibility aspect of things, right? So we understand the models that you're using, and this is an ultimate goal that we have, and we're a bit away from it today. But if we understand those models, we understand the infrastructure, we have the data, right? We become pretty intelligent on what though how you exercise that information. And what has to happen is like, okay, you're using this model, you have this data, and you have this infrastructure. We understand the compute that's necessary from that. We understand the network that's required. We understand the resources that are available to me. So let's optimize that. And we actually would be kind of cool too to understand the data I don't have,
Hmm.
right? That won't allow me to execute that model in its full capacity. So that's the level of insight that you're going to see from Peak as we move up the stack, right?
Hmm.
It's important that we put that foundation in place because it optimizes things above that.
Hmm.
And we got some work to do, but we're excited about where the future is headed.
And
Uh,
it's, the whole notion of the work is kind of interesting too, because, like we said earlier, there's the gigantic world eating model of a weather simulation, and then there's
Hmm.
the kind of giant, cluster consuming, say, model training for deep
Yeah,
learning, which is bigger than, say, fine tuning, which you can do multiple distillations or fine tunings of models to use up pieces of a cluster. And, but there's that kind of high performance computing side. The AI side, there's the build side, which can be
yep,
very cluster
yep,
compute consuming, but it's not that concurrent in that you only have one or two things running in the cluster on different nodes. But then you get to execution if you're actually running your
yeah,
own things, then you have a whole lot of concurrency, but they're individual things running on one server as opposed to smeared across many. So like the
yeah,
the AI market itself has different workload characteristics versus data science and machine learning workloads where the
yep,
models themselves could be equally complex, but they don't consume as much data and they're not as parallel. And when you look at the prevalence of work that a company needs, let's say a large corporation needs, um, you might have one thing that looks like HPC and two things that look like
yeah.
big AI training and 50 things that look more like large, machine learning or simulation or
Well,
something.
yeah, and we're seeing it in today. As we talk to our partners, 90% of what they're seeing today is inference, right?
Yeah.
Those are the workloads that they're working. We've seen that in the history of AI, in the short history of AI, right? And that's what's great about Peak AIO is we have a remember back to the beginning of conversation is we have a single node can give you line speed performance. So that can go directly to the edge to do some really incredible, intricate things.
hmm.
It can be used as a great inference box. Federated training or federated learning is a big, we're doing this to get we're doing this to get closer to the data, and we're doing this to get more intelligence at the edge, and we're a great fit for that. So when I talk to organizations at the enterprise level, it's like it's a single platform that you can start from a single node at the edge all the way to the scaled out models that you want to run.
Hmm.
So yeah, I totally agree with what you're saying. And you need a solution, and you need a partner that can provide that infrastructure, because that infrastructure is dependent upon both scale as you grow, but also the other things you have going on within AI.
Hmm.
Right.
And the inference you talk about, that's the value, right? I mean,
Yeah,
everything leads
yeah,
up
Yeah.
to the inference, which is where you get value from all that investment, right?
yeah, exactly right.
Yeah.
Yeah, I mean that's the thing. You spend, all this time training or tuning or
Yeah,
simulating or whatever, and then you get to the point of deployment, and then this little bitty thing goes out
yeah,
on a phone,
yeah, yeah,
or
exactly.
yeah, or in this case, a lot of stuff is running on servers. They're still GPU servers, but they're just running for very short periods of time.
Yeah,
And that's where you end up with a very different sort of workload cluster profile. The other
yeah,
thing, to point out is I've seen people actually, go out, fill a data center full of, really expensive GPU computers, get a reasonably good network, which we keep skipping over, but without the network, none of this
yeah.
works.
Very
uh,
true.
high-speed networking, and then the storage is sort of like, oh, we just went out and bought some, or we tried to repurpose our network attached storage, and then of course that's the bottleneck because that was built to either serve files or serve a database.
Yeah, yeah,
And
exactly right.
when you look at like an AI workload, the database has a few big files within which all the records are stored, and so you kind of open those things up and access them. You're talking about inferencing or model training, and you've got on the training side 1 billion 2 kilobyte files, right? So
Yeah.
it, how do you even store that stuff and manage that is completely different than the next, the other side of it.
Right. Right. Well, let's pick this up after the break because this is a very good question for Roger, and he probably wants to think about it for a second. We're up to our break anyway. So we're talking with Mark Madsen of Third Nature and Roger Cummings of Peak AIO, all about getting, guess what, peak performance from your AI infrastructure. And the whole point is inference. That's the point you want to get to, is where it goes, I think you should do this instead of that. And it goes to a consumer, to a business partner, or whatever. We'll be right back. You're listening to Inside Analysis. All right, folks, back here on Inside Analysis, a scintillating conversation with Roger Cummings of Peak AIO and Mark Madsen of Third Nature. And, before the break there, Roger and Mark was talking about the disparity between what you need to do to build one of these big models and train one versus use them on the other side. And a lot of times companies have to use the same infrastructure to do that, which is very odd. I mean, someone was giving an example the other day of, of horses for courses, as my old radio partner used to say, meaning there are certain machines or horses that are good on one track and certain that are good on another track. And if you have the same horse, then you have to find ways to make it work well in these other environments, because you're going from, building this huge thing with just a handful of people to serving thousands of people wanting little small things from it. That's a very different profile. It's a very different architecture. So how does Peak
Hmm.
AIO fit into that equation?
And I think I think you're absolutely correct. And what has to happen, at least, and we've seen this movie before with other technologies, right? Is you have to have something that both scaled out, right, to address those training applications, and then scale down, because that's the maturity of an AI cycle, right? I've collected all this insight and information. I've collected this, and now it's the time for me to build that inference, right, and push that inference out into the field.
Hmm.
But I think, and I also see a maturity happening on the inference side of continuously training in the field. So it's a dual purpose, and what we've done for a couple of our more mature accounts as well is we've done things like training, inference collection of the same box. So
Mm.
that's a great application for that maturity model that we talked about here. Repurposing, taking the information, pushing that inference out to the field, collecting that edge training and providing inference, pushing that training,
Interesting.
new training information back to the master model, and it's a closed loop process that's happening.
Hmm.
So that's a great example. It's one example that we provide both in servicing these large scale out models as well as the inference close to the edge,
Hmm. That's very
scaling up
interesting
and
stuff.
down.
And you're kind of teasing up a question that just popped into my mind, and I asked this of a lot of different people, is small language models. There's all this emphasis
Hmm.
on bigger and bigger models and, billions and billions of parameters and, the latest chat GPT version 5.0, which was interesting because they said, yeah, you can't use those other ones anymore. Just use this one. Like, okay. Some people weren't too happy about that. But bigger isn't always better. And I think right
No.
sized is what you actually want. And granted, we're very, very early in this evolution. Even though AI has been around for 30, 40 years, there have been a couple winters, obviously. I don't think another one is coming. People talk about a bubble. Maybe, but God, there's so much money. It's almost like too big to fail now, right? With all this money
Yeah.
being thrown in. But what do you think about smaller, more focused models? Is that the future of really good granular value for businesses?
I've seen and we continue to see examples in healthcare from image collecting multiple images, collecting those multiple images in the field, and not sharing patient data because that's not appropriate in many countries. But sharing that inference on improving that inference from the field,
Hmm.
and I see that happening more and more. We did a project with the London Zoological Society where we were collecting training data from thousands of cameras and trying to save the habitat for the hedgehogs out there. But it
Oh,
was using image recognition uh, technology, where we were just grabbing that the training data and improving that inference model over time. So I think we're coming from a world of training at mass scale, right? And I think we're maturing into a training at the edge,
hmm.
and that requires a much different infrastructure.
That's interesting.
Yeah,
More.
it's kind of like the shift. It echoes so many things where it seems like you just build one giant thing, it's going to be easy, and then it'll all be
Yeah,
centralized. And of course, you end up with like OpenAI and Anthropic building giant language models that claim to
yeah.
do everything but do nothing well. And
And to your point, though, but to your point earlier, it's about the inverse, right? It's about
yeah,
you've
yeah,
created that huge model. How are you going to use it now? You're going to use it
right,
in a very disparate, disparate fashion.
right.
So it's exactly what you stated.
Yeah, and so, we're not trying to build like one, like everybody's going to drive an 18-wheel tractor trailer to and from work
Yeah,
because they're really useful.
yeah,
When you move, which you do every 5 to 10 years. And so, the idea of small focused models and not trying to chase this, oh, we're building something that can do everything, like the
yeah,
everything model. I see that as the future too, but that just points to lumpy looking workloads and a
yeah,
cluster that's going to be allocated 50-50 for two things, and then it's going to be 75 this, 25% that.
yeah.
And that 75% will be, high concurrency, lots of like, when you say inferencing, it just really means lots of small amounts of data being shoved through the model very
Yeah.
quickly at low latency because you're, like you said, at the edge. And that that whole thing looks different, is organized differently, but
And
yeah.
think about the tactical edge applications. That's a great
Yeah.
example of it, right? And there's a ton of tactical edge applicability to this type of small to large, large to small infrastructure.
Yeah.
Hmm.
So, looking at some of these things, one area that we didn't talk about because it's like gets sort of technical is some of the hardware drivers of this market. What does it mean to buy an AI server? We just slapped a label on it, but
Yeah,
if you look
yeah,
at those things, it's like, oh, well, it's a computer with a GPU. Well, it's a computer with like video RAM and a GPU and specialized motherboards and The GPU itself is only a piece of it because if you want to do like super high volume training at speed, the
Hmm.
path, like in a computer, I don't think anybody understands the path to data, right? That
Yeah.
there's memory, and then there's the CPU, and then the CPU talks to the I/O card, then the I/O card talks to, like a flash drive or something. And of course, there's like 80 hops in there, but we hide them.
Hmm.
But then you do this with very large storage, and the storage isn't local. It's over a network. And so all these optimizations that companies like NVIDIA and AMD and others did that allow a GPU to access memory without talking to the CPU, and that allow GPU to talk to a GPU in another computer and
Hmm.
Hmm.
access its memory at the same time, these remote data access protocols.
Right.
And
Yep.
then the GPU to talk to that other thing, instead of trying to talk through an I/O controller, you talk through a network interface controller because there's no storage locally. And then
Exactly.
somebody came along and said, hey, let's build a smart network interface controller that bypasses the actual kernel so that you never talk to the operating system. It's the GPU talking directly to the network interface and bypassing everything else in the computer, at which point you're sort of like, what is the computer? It's a skeleton, to
Yep.
host the parasite that is the GPU plus its smart NIC plus everything else. And like
Hmm.
these are very different beasts. And I feel like there's not a lot of appreciation of that that leads to having to rethink how all these bits work. But behind all of it is just one simple fact in my mind, and that is, the speed of light is the limiter of everything, right? And so,
Yes.
how long does it take electrons to go from point A to point B? And how long does it take for the other electrons to come back, and whether they're stored on a disk or flash storage or a remote GPU doesn't really uh, it doesn't matter. And so all the optimizations are about moving those bits
Yeah.
with you know such low latencies that like what Roger was saying was talking about line speed, right? I mean, you're just talking about how fast can that GPU in that server do that thing and turn it around to you? And that's a big, complicated stack of stuff that you have to orchestrate.
Yeah,
Right.
and in order for us to be successful, us being the IT industry, and for AI to be successful, we've got to take everything you just mentioned there, which is incredibly valid and exactly what people need, and make it brain dead simple. So
Right.
how do you take all of that and make it very simple? And we're doing some things that allow, if we have a tremendous amount of IP, probably the majority of IP sits on simplifying that administration of all of those things.
Yeah, let's pick that
So
up for the
you're
break.
absolutely right.
Final
Mhm.
break. We'll be right back. All right, folks, time for the podcast bonus segment here on a fascinating inside analysis with Mark Madsen of Third Nature and Roger Cummings of Peak AIO. And Roger, you were just saying the IT industry needs a way to simplify things. And it's interesting because you basically just described my job. Like that is my job is to simplify these complex terms and make it easy for the business to understand that there are very serious trade-offs in terms of your decision making of what you do here, how you leverage AI. Do you want to just use a large language model for, for some task or some optimization? But all this agentic stuff, it's a whole different ball of wax. It's very, very
Correct. Yeah.
different than large language models. But like, how are you going to use AI? What always have the business purpose in mind? A lot of times it's classification, a lot of times it's automation of processes like around either getting revenue or optimizing supply chain, for example, which is a really, really complex set of tasks. And from what I understand, SAP has been doing some very interesting stuff in that space. But let's just close off on how Peak AIO is serving as this again. It's a software layer that sits on top of the storage environment, and so you're taking what a company already has and saying, hey, let's optimize what you've got to fulfill your particular purposes, which of course the business has to understand and articulate. And then there are the other side of the equation is when you plug this stuff in, like where the inference actually gets plugged into the business. Is that in some screen rep on a portal that your employees
Yeah.
are using, or where does it actually show up? But go ahead and finish up just kind of explaining how you're sitting on top of all the storage, that's the data
Yeah.
that's going to be needed, whether for training or for inference, and you're optimizing that path, which is a pretty useful thing, right? Go ahead.
Yeah. So our goal is to provide a single data platform for all your AI workloads. And it has to be, number one, it has to be simple to use, easy to deploy, right? Environmentally friendly, right? And at a cost and RTO perspective, right? That allows you to fail sometimes, but allows you to grow and expand and scale.
Hmm.
So you really need that infrastructure that's going to allow you to do that. The you have the servers that are out there. Incredible technology is done on the servers. You have the disk providers out there. They're continuously improving the density of those disks. And then you have, of course, the compute layer and the switch layer that are making their innovation, pulling this complexity together and making it simple to use, simple to deploy in a cost-effective manner uh, for any AI workload out there today, and that's what we do in a
Hmm.
very simple fashion. And the great thing about our innovation is you can start in a single node 2U server, dense. What is it? Solidine 122s behind it. Make it 6 petabytes in 2U if you want, and you can do that with our solution for under $25,000.
Hmm.
And you can run a lot of the workloads within that single infrastructure. Now you can scale that with a file system. So we're excited about the future.
Yeah, and Rogers just did something amazing in the world of enterprise software, Mark. He actually quoted a price.
Yeah, yeah,
That's
yeah,
that's honesty for you right there, folks. Usually it's like, oh, how much does it cost? I don't know. How much you got?
Yeah.
yeah,
How hard is the pain point that you're experiencing? I don't know. Final
yeah.
thoughts from you, Mark. I think this space is white hot, and we need multiple levers we can pull and dials we can turn to be able
Hmm.
to optimize what we're doing. And that's one of the cool things about the technology these days. You can do that. You can even do that with large language models. You can say, all right, I want it to be really clear, or I want it to be really fast, or whatever. And you've got these dynamic capabilities. But what are your closing thoughts, Mark, about where we're heading and where companies like PKIO fit into the equation?
It's really hard to manage infrastructure, right? We've
Hmm.
automated so much and we've built layer upon layer upon layer inside computers, inside clouds but most of what we build is just hiding all the sharp edges so you don't cut yourself. If you go from
Yeah.
where we were to where we are,
That's funny.
and like ease of use to me, if I put on my I'm an enterprise guy like I used to be, it's like, well, I need to add storage. I need to remove storage without taking things down while the system is up, right? It's not
Right.
Yeah.
like I'm swapping disk drives and shutting it down for the day. And reallocating on the fly when I'm using it for this and now I'm using it for that, and being able to simply make sure that this data goes over there or that data goes over here so that things work. And then in operations, it's the how fast is it? Do I have, I have a performance problem where things are lagging. Why are they lagging? And, you manage that in layers too, but you've got to quickly diagnose, oh, it's here and it's getting data to the process quickly enough. And so we need to go into peak AIO and it has to figure out, well, it doesn't have to figure it out. It has to just tell me where is this and what's the cause
Hmm.
so that I can figure out which levers to pull and what I need to do to recover from either a failure or just a problem. And so there's different elements of ease of use in here that are just about using and hiding that complexity. And that complexity in these markets tends to leak through. And that's my big complaint about most of it. It's like, oh, this is easy until, oh, darn, quantum physics.
Yeah.
That's pretty funny. Yeah, that's a very, very good point. Well, I'll tell you what, this has been a fascinating discussion. I'm sure we'll be hearing more from Peak AIO. Look them up online. It's PEAKAIO.com. And of course, Mark Madsen of Third Nature. We're booking out the rest of this year right now, folks. If you want to be on the show, send me an email, info@insideanalysis.com. That comes straight to me, or info@dmradio.biz. But the AI revolution is well upon us. I think that both Roger and Mark made a lot of good points today. Fail fast forward, experiment with this stuff, use these things, use the large language models to kind of understand what they do well and what they don't do well. And they are kind of tricky. I mentioned something recently that a lot of people don't know, and I only know about it because of a friend of mine who asked me to look into this. Uh, ChatGPT in particular is biased towards you. So if you are like I am an analyst firm, and if you ask it, what are the top 10 analyst firms, it'll be sure to list your firm in the top 10. But if someone else asks, hey, what are the top 10 analyst firms, it'll list their firm and it might not list yours. In other words, it's
Yeah.
not objective, right? It is subjective and it's trying to, play up to you and, oh, thank you. I love how obsequious it is, quite frankly. It's like, oh, you're right. No, oh, good point. Sorry about that. It's like
Yeah.
most people don't do that, but the little chatbots, oh, I'm very sorry. I'll get it right next time, sir. It's pretty fun. Well, folks, fascinating conversation again. Peak IO and Third Nature. We'll talk to you next time. You've been listening to Inside Analysis.